Thank you very much. I won't make this a marketing event. Okay, good. So I won't be boring you with marketing slides, hopefully. I'd like to keep this as interactive as possible. So if you have any questions, raise a hand, ask a question. If you disagree, raise your hand, and we start discussing. So it's not meant as a lecture, more meant as a interactive discussion with the whole group. I'm not loud enough. So let me start with something called objects. I guess many of you are familiar with AWS, aka Amazon Object Storage, or has any of you heard about Netflix? So you've been using their stuff. So in the object world, you're not storing data as a file. You're storing it as an object. This object has metadata associated to it. That means you can put descriptions on it. You could even use object storage in your own areas. So if we're working with physicians, they often store X-ray data. Composes of images, and these images need descriptions. Who's the patient? When did I take the picture? What part of the body is the picture? Of course, the doctor might know, but the system, when you search for the X-ray, doesn't really understand what's inside the picture, so you need to enrich it with data. And I took some of the statistics of Amazon. So in 2010, 7 years ago, they've been storing 262 billion objects in their cloud. Their cloud started as leftover. So when Amazon started their cloud, it was leftover servers they had from running their SAP system. And one of their guys, Bernhard Vogel, had the idea, let's rent this stuff out to the public. Since we don't use it from Monday to Friday, we can rent it to people. These systems only computed on Saturdays and Sundays. And in 2017, Amazon is the largest cloud provider. They did cloud by mistake, but their object store simply increased. They stopped reporting in 2013. They stopped reporting how many objects they stored. So you can make the maths. It's probably 8 to 10 trillion objects in their object cloud at the moment. Each and everyone who has a credit card can use their services, but it always comes at a cost, and the cost is security. You're giving up your data. So your data is somewhere up. At Amazon, about 8 weeks ago, they had a little outage. Somebody typed in the wrong command at the wrong prompt and killed the block storage for just 8 hours. No problem, you might think, but a couple of customers lost $300 million in 8 hours. Because the whole of the Disney imperium is hosted on Amazon. Netflix is hosted on Amazon. If their service fails, you can't access them. And one of you asked this question this morning, I think it was you, the data local and the storage in the cloud. I'll show you an example how we do it. So your data stays your data. You don't have to copy it over to somebody outside the region, outside the country, but you can still use the compute and memory resources of the cloud. So why do objects matter at all? There's some stuff that you always need to take into account. How many copies of my data do I need? Is this something meant to be persistent? Or is it something that I just need for 10 minutes and I can recreate it very, very easily? So if you run scientific projects, some of this data is just throwaway data probably, but some of the data, especially the results, if you're running them on HPC computes, you can't just restore or redo the project within 10 or 20 minutes. So you need to keep the data. And sometimes you might want to exchange data with different universities. So the data doesn't stay here locally in Gießen. You might want to share with Heidelberg, or you might want to share with the university somewhere else on the planet. So you need to copy around the data. And I think many of you are familiar with a protocol called NFS, or heard of the name NFS, or SMB. Those are file-based access protocols. And there's a huge difference when we compare them to objects. File-based protocols always need to maintain a lock on a file. So only a single person can change the file at a time. So if you put a Word file on a share and you start editing and someone else starts to edit the same file and he would save faster than you do, without locking, your work would be lost. Then you start saving and his work is lost, and so on. This is why some brilliant minds implemented locking mechanisms into files. So when you open the file will tell you, sorry, I'm being edited by Mr. Mustermann, and he's now in charge of the file. Would you like to have a copy? Have a copy and a copy and a copy. At some point you need to merge those, which is annoying to say the least. In objects, you don't have locking. So you touch the object and you're creating a new version. That means whenever you've done something wrong, you can just jump back to the original working version. And that also gives you the opportunity to scale object-based file systems infinite. There is no physical limit. Of course, there is the hard drives you use. If they are full, you're out of luck. But until then, you can store as much and many objects as you would like. And each of them needs to have metadata, whereas a file doesn't need metadata at all. Yes, of course, some file systems save metadata, but you don't really need it. This is why browsing in file-based systems is always a bit more expensive when it comes to compute resources than in object-based resources. But how do you keep track of what? The simple solution is what we call buckets. Think of a bucket as a tenant. If you're familiar with the concept of tenants, you can separate entities into different buckets. And each bucket can have different access rights. So you could define a read-only bucket. So Bielefeld, for example, stores a file and adds read-only permissions on it and hands it over to Heidelberg. Heidelberg can read the files, but you cannot change these files because Bielefeld only gave you the permission to read the files. But you may want to have a shared bucket for images where each of you can store data in it to exchange files, for example. Or if you finish your project, the whole team can lock the bucket and simply give it out to other people. Those buckets cannot be accessed directly like files. In a file system, I have a file which is called image.jpg, and I can access this file because I can see it. In object-based, I need to have the identifier. So I need to keep my access key. S3 is a common protocol. You can use it on Amazon, but you can also use it on compatible devices. So even under Linux, you could build your own S3 compatible store. There's also something in OpenStack called Swift. This is something that I think Burkhard is trying to implement here as well, if I recall right. So there will be an object store here at University of Gießen also. But even then, they call their buckets containers. So everybody uses a different name, but they are all saying the same. These containers also contain whatever you put in them, whether it's an image, a text file, a video, it doesn't really matter what you put inside as long as you describe it. For certain things, if you finish your projects, you might want to apply something called warm onto them. Write once, read many. You're writing the data once and then you're archiving it for the next 10 to 15 years so nobody can play around with your results. This is when you put them onto a warm policy. That means nobody can delete your precious work. Somebody tries to change your work by putting his name instead of yours onto the project, a new version will be created. So you always know who did the change. The main benefits of objects are compatibility. So each of these projects work together with OpenStack, no matter which flavor of OpenStack you're using. We heard this morning that there is basically around 25 different OpenStack flavors at the moment. Each of them uses a bit different operating systems. The main distribution is still called Vanilla. This is what you're seeing here on your screens in the hands-on workshop that Burkhard created. But every vendor has their own OpenStack distribution, is what they call it. But basically, they are all talking Swift, S3, Heat. Some of them can talk Docker. More to this later. The main idea is to have something REST-based. The REST API means that you can always access the resources in the same manner. You don't need a specific client for it. The most annoying thing with open source projects is if the developers start doing something else. During their study times, they work on it, but maybe during summer they take a break, they don't fix bugs. Some of these open source teams stop at some point because people go off working somewhere else, or they start to fight and discuss over certain things, and the project stalls. But with data, a bit of a problem. So if you put your data into an object-based storage, you want to access it for quite a long time. You don't want to be at a point somewhere where the founder of the open source project or the company behind it says, sorry, we don't support this anymore, please copy your data somewhere else. Of course, if it's a terabyte, no problem. But if you're at around 100 or 200 terabytes, you won't copy them overnight or migrate them and have to change every little access point. So the object is something that you can always use, and there's something in it that is also called efficiency. Have you ever heard of the term compression? Just raise a hand if you didn't. Sorry, just wanted to confuse it a bit. What about deduplication? Okay, so you never heard of deduplication? Sorry? So it's just the ones who never heard about deduplication. So if I have two objects that are similar, one gets not stored and gets linked to the other. That means if the other gets deleted, the linked one will be copied over. If you have a large object storage, you don't want to store the funny picture of Monday.jpg 212,000 times because everybody had this in their inbox. Or if you have a website, for example, the University of Gießen website will have the university's logo quite often, I guess on every subpage. Would you store it with every subpage? No, you wouldn't. You would put it once on your web server and link to it. Basically, the same happens in your storage. Write it once, you protect it. This is what we call data integrity. So even in deduplication, we're using an algorithm called hash. So we're building an MD5 checksum of a file, and then we compare them to each other. But there's a scientific possibility two different files get the same MD5 sum, even though they have different content. In this case, deduplication would kill our data integrity. Rule of thumb in a storage company, your data may be slow, your data may be offline for a few hours, but you may never, ever corrupt your customer's data. The same applies to you. If you can't deliver the data you've stored or read it after 5 or 10 years, if you need to revisit a project, you have a bad day, probably. So this is why we're implementing so-called health checks. So even if we store a file on a hard drive, we will touch it from time to time and see how it is. Is it feeling good? Is the integrity still intact? The same applies to hard drives. I guess most of you have used tape libraries currently or in the past. At some point you might, yes? Sorry? Yes. Yeah. It is mainly for historical purpose that MD5 was established. So most of the developers in current storage companies shy away of using something new. So this is why they're keeping MD5. So far, there have been no hash collisions in deduplications in the whole market. But there is still a possibility that this could happen. In the product I will be talking about later, we'll be seeing that we're doing it a bit different. And we're asking the entity who stores the actual block, do you have a block with this content? Or do you have a block with different content? So we're asking the hard drive, the one thing that is responsible for storing the blocks, in the end, whether the blocks are different or if they are the same. So far in 45 petabyte, over the last 8 years, we didn't see a single hash collision. This is just an example of a photo repository. I think most of you have seen the TV adverts of a company called CWS with their funny little photo apps and when you can print out the pictures for your family. They are using StorageGrid, which is an S3 product of our company, in order to store their data and to retrieve it. I've been visiting a healthcare company last week, and they are storing the receipts from pharmacies. So if you go to a pharmacy and you buy a pack of aspirin on your doctor's receipt, they are scanning it. And they are sending this to a central location in Munich, and they are processing the payment to charge your insurance company. The developers started with this project in 1999. Thought 8-bit TIFF pictures is the best idea to store this. And they created monochrome pictures with monochrome barcodes. Turns out in the end of 2017, they will run out of monochrome barcodes. So, and in Germany, we have the law, everything that is associated with a medical record needs to be archived for 30 years. I don't know who will ever read this data, but we are obliged to store this. So one of the developers had the brilliant idea, let's introduce colors. So what happened with our 8 kilobyte TIFF? It turned into a 256 kilobyte overnight. The IT department didn't really calculate with a data growth of more than 3% a year. And they did it overnight. So their only option was, I'm just running to my boss and I'm asking for a whole lot of more storage overnight. It's nice in a leasing budget. Yes, Dr. Gößmann knows the budget fun when it comes to asking for money, especially overnight. Or they had to reprogram their software and store everything in object-based format from now on. They went to object-based because they said we don't need high performance for this. We need to ingest a lot of data, but the possibility that over the next 30 years somebody will come and ask for my aspirin receipt is quite low. This is why this little hardware piece helped us. StorageGrid is an object-based solution that features a global namespace. So I can enter my object cloud at any given endpoint, and I can see whatever I'm permitted to see. So I could spread this over 3 different locations in different countries. They don't need to be local. They don't need to have high bandwidth links. So you could live with your 2 times 1 gig, even for StorageGrid. They communicate over IP. You can choose whether you want to send it over VPN, MPLS, if you want to encrypt or not. It is completely up to you. You need to have an admin node, so you can do changes to the configuration. And afterwards, you just distribute storage nodes all over the place. Could be 1 central location, could be a couple locations, could be 2 in the main, 3 in London, 4 in New York. And then you simply start writing towards it, whether you want to use the S3 protocol, whether you want to use Swift, whether you want to use a backup product, or if you simply want to use it over NFS and CIFS. The product really doesn't care, as everything you do is storing objects into it. And you have the ability to put an object somewhere and read it at some place else. So you could set up a policy that says everything that goes into Amsterdam is being read in New York, but they only get read-only permissions. So you can share data with them. What do you have to do? You have to create a lifecycle policy that says 1 copy, 2 copy, 3 copies. So if you look at traditional storage, you're typically setting up a bunch of disks to a RAID. You say, I want to have RAID 5, RAID 10, RAID 6, depending on your performance and reliability needs. In here, you simply tell the system how many copies of data do I want to have in what location. You could use erasure coding, which is not RAID per se, but is something very similar. And I can read my objects wherever. And I could even say, since London is going to the Brexit, they don't get any European data anymore, so I just remove the European share from London and keep it between Amsterdam and New York, if wanted. The namespace, aka metadata, is available immediately. So if I create the file, it will appear on the other side. They cannot access this instantly, but they can see, hey, there's a new file. There's a new receipt for aspirin. from a patient. So they know something has been done, but they can't just access it yet. If they start accessing, the file will be copied over. So you could say, I have a project team over here, and I want them to see the current folder of June, July. But I don't need them to have May and April. So I just set up a policy that will mirror the needed data to them. After the project is done, I can simply remove the access. The files will be copied empty, and everything will vanish from that location. And this applies to almost everything. So I could even define a policy for videos. I don't want videos to be transferred from London to Amsterdam and to New York, but I want them to be safe. So I distribute them among my 3 existing nodes. So I have some sort of logical rate. That means if a node goes foobar, nothing really bad happens to my data. It is still intact and safe in that location. Or I can tell it to store the copies all over the place. So even if London burns down, I can access the data in New York. I can also do something called offsite backups. So I could store the data somewhere outside in your own Swift repository locally, in Amazon if wanted, or if I'm conducting research with a public company or a private company, I could simply upload the results always to them because they are the copyright holders or involved in the project. We don't really care where you install your storage grid. If you have VMware, fine. If you're more into KVM, no problem. If you like Docker, also possible. If you favor OpenStack, no problem. If you want to buy hardware from Heiko, also no problem. He'll be happy. And it's completely open. All these things need to each other is IP-based communication. So coming to containers. How many of you heard of IT containers, not ones on the trucks? Okay, so quite a few. Who has never heard of the concept of a container? Just like, okay, it's no problem. This is why we're here for. Containers are something different than a virtual machine. A virtual machine is always a full-blown operating system. Think of a container as something like if you go on a little exhibition and you pack your suitcase at home, you will pack everything you need into that suitcase. Underwear, toiletries, possibly shoes, handbags, whatever. So you would pack it all together. So whenever you go out, you take your suitcase and you have everything pre-packed. If you ever had to fiddle around with Java and their different versions and 10,000 patches, you would love containers. Because if you're developing something in Java and somebody on the other side that you want to run your program, he has a different Java version. Could end in funny discussions. He would claim the application is not working. You would claim, no, it's working fine, until you both see that there is different Java versions involved. And the one on the other side is too old or too new, and it doesn't want to run your code. So with containers, we're packing up everything into a container, the required libraries, the application, and we can execute it on every operating system. So if you favor Ubuntu, you're favoring Debian. Here we have somebody who likes SUSE. Please don't shoot me. You could just exchange the containers. We started adopting containers in our own development because we had different religions in the company. One of them claimed CentOS aka Red Hat is the only available Linux. Then we had a couple of people in India who favored SUSE Linux and Ubuntu, and we had some crazy guys in the Nordics who loved their Gentoo. But they didn't work well together, so everybody had to apply their own patches. This is why we moved to containers completely, so we can jump between versions, and especially in our own storage grid setup, everything is container-based. So if we have a new version, we will roll out a new container, the old one will stay intact, and with a single click, you can just move back into the version if something goes. And yes, speaking of SLES, we used SUSE Linux Enterprise in the beginning, which was also a pain point for many customers because they said, We don't want to run the enterprise version of that Linux. We don't want to run a commercial Linux. We just want to run Debian or Ubuntu in any flavor. But we don't want to pay a company for providing us Linux binaries. And of course, there's no complete OS installation involved. You can simply start by rolling it out on any kind of hardware. These are just screenshots from the operating system. I will go into this live later. I just left it in the presentation so you could look it up afterwards. I will jump over the text-based slides a bit quicker, so we don't need to waste time here. Versioning. So whenever I put something into my object-based file system, I might have the same access key, aka name. Otherwise, I would have a problem if I have more than one person on the system and everybody wants to store report point doc. With metadata attached, I can have different version IDs in the same bucket. So even if I delete the file or object, I can always restore it. And if I write it new, I don't see the old data, I see new data. And then I could simply filter and say, okay, give me just the latest version if I'm trying to find objects or search for them. I'm not interested in the 150,000 previous versions of report.doc. I'm just interested in the latest version. Same applies if you run a wiki or if you're running a site where students can download documents, like register for eduroam Wi-Fi, the new Mensa plan. You're not interested in last week's meal, you're interested in what's happening today. So you could just say, give me the content of my report, but always the latest version. And the one person who is uploading the file, he doesn't have to care about, do I need to put the file in this folder, that folder, how do I name it, do I need to rename the old one? I can simply work on the same report.doc. Just changing the isLatest to true will always give me the latest stored version. I don't have to think for all the possible steps anymore. And even if somebody deletes the file by mistake, I can always reclaim it. OpenStack. You've seen in Burkhard's presentation that OpenStack is not just a tool. Sometimes it's being mistaken as a hypervisor. So I had a lot of customers who told me, yeah, we're moving away from KVM, we're going OpenStack. Cool. But doing the same, just in a different GUI, if you name it this. There's a few projects within OpenStack which are worth talking about. One of them is Swift. It's the object storage. There's, of course, Nova, the compute part. Nova can interact with a lot of hypervisors. Hypervisors are the ones that are running your virtual machines. So there is support for VMware. There is support for KVM, for Xen, but also for containers. Also run ELIXIR containers under Linux. You could run Hyper-V if Microsoft ever opens the API. Then there is Cinder. Cinder was actually created by one of our guys called John Griffith. He had spare time and he said, we need a block storage in OpenStack. So he sat down and created Cinder. We're still employing quite a lot of open source developers in our company. So their sole purpose is create open source code. We don't charge for this, we just provide it, and it gives us the opportunity to change our systems so they interact properly with these APIs. And we're one of the first OpenStack users globally. We were the third customer after Rackspace and NASA put their heads together. The Americans always say is eat your own dog's food. It's just a common term. So we're using OpenStack to develop our own microcodes and software. The main idea behind it is to support all those kettle workloads. Are you familiar with the term pets and kettles? Probably? Good. So our idea is to just provide a framework so we don't have to push you into a corner and say, you have to buy product XYZ, you have to run hypervisor ABC, and you have to have version MNL. You can use it as long as it speaks the common protocols that are being used in these projects. Talking about what's powering the cloud here, it's called SolidFire. one of the founding members of Cinder, the founder of SolidFire, was working on the original OpenStack project. He was head of storage at a company called Rackspace, one behind OpenStack, and he was tasked, go find a storage solution for OpenStack. He said, fine. So he created a RFI, went out to the market, and everybody who could write down hard disk on a sheet of paper came and wanted to showcase their solution. He said, wait a moment, I need you guys to have 5 different key elements. One of these elements is scalability. There may be no physical limits on how far I can scale my storage, but there should always be the possibility to scale back. The Americans always think about scale out, go larger, go bigger, but at some point you might want to reduce a project, or you might want to change the existing world that you have, or even after 5 years, if your hardware is old, you might want to replace it. So for him, scaling was very, very heavy. The next thing is data assurance. Our marketing always put it in as self-healing. I've not yet seen a self-healing server or a self-healing hard drive, but the infrastructure must always tolerate physical loss. Even if you go into the data center over there and steal one of Burkhardt's machines, the cloud will still work, as long as you don't steal all of them. Guaranteed performance, as there are different departments working on that solution. You don't want to have them fighting for resources, calling Dr. Gößmann, saying, my project is more important than the other one, give me more. Or it feels sluggish, so you want to protect them. Automation, Burkhardt has now not enough time to pay Mr. Storage 24 hours a day. So there is need for automation. So if you create a new virtual machine, old-fashioned IT would be run a ticket, describe your project, tell them the size, tell them how long you need it, how fast it needs to be. Where in 2017, you want to click a button and you want to consume resources. It's like going to the Mensa. You don't want to bring all the ingredients, hand it over to the cook and say, give me a meal. You just want to go where the best, nicest looking picture is, and then check out your food and consume it. And the last thing is called global efficiencies. That is basically including deduplication and compression. Deduplication should always happen on a global matter. So you're not deduplicating just on a single hard drive. Shouldn't matter where you put your data into your cloud. It should be intelligently deduplicated. Dave was unable to find all of these 5 points in a single product. So he quit, created its 5th startup at that time, and started developing a hardware product. That happened in 2009. In 2011, he came out with the project and grabbed quite a few customers, smaller ones such as eBay. So if you ever visited ebay.com or ebay.de, you spent time on a Netup SolidFire system. Or if you exchanged money over PayPal, you basically did the same. Or if you've heard of the German company 1&1 and have used their mail system, website system, you've already used this cloud-based technology. Integration. We've heard about Cinder. So yes, it says 6 lines of code. The last 2 are only needed if you want to give different names and want to have prefixes. Otherwise, your whole block storage implementation is VI, Emacs, or your favorite editor of choice, and 4 lines of code. Then your block storage integration is done. Afterwards, you can simply start by creating your volumes, by setting quality of service on them. Quality of service basically means you get 3 different resource informations. There's something called min IOPS in OpenStack that will give you a guaranteed bandwidth on your storage. There's something called max, which will block you if you consume a certain amount, and there's something called burst. Burst works like your bank account. If you've behaved, the bank will say, okay, your credit limit has just been increased, but whenever you want to use this extra credit line, you have to pay back at some time. The system basically does the same to you. No, we don't charge money, but we will give you 60 seconds of burst if you've behaved before. This is similar to what Amazon does in their cloud. So if you've stood below the maximum amount, you can burst for a minute or two, unless you would harm a different instance that has a reservation. This happens in the background. This happens automatically. You don't need to manage it. You can give the user permission to burst, or you can remove this permission from the user. The concept behind it is not turning bad software into great software. The concept is removing that annoying phone call, oh, my application was just stalling for 30 seconds, why? People tend to forget things like backup. I know nobody cares about backup, everybody likes restores, but the idea is to simply overcome short, sluggish problems in bandwidth. Once you have your images, you can create a bootable volume. This is what you've basically done in the last session. This is just as a little repetition. And of course, you can create systems directly over Cinder. That means you don't need to burden your virtualization host, no matter what type of virtualization it is. You can simply tell it, use the existing volume and clone or create it in the storage backend. So there is no block exchange between the virtualization host and the storage system needed. This typically results in 10 to 20% more performance for your virtualization environment. This is just a little screenshot how to do quality of service in a graphical manner. If you like the mouse, you can do it in the GUI. If you like the keyboard, there's a CLI, aka REST-based API. And with this integration, you can simply use whatever tools you like. I think there's an Ansible track this week, tomorrow. So you could use Ansible to do it. But if you like Puppet or Chef more, simply use them to automate your environment. If you want to do it over Java, use Java. If you're more familiar with C#, use C#. If you want to do everything by Telnet, of course, do it by Telnet. We're also open to this. The API is programmed in I always tell it it's a customer happy version. So we will add new functions to it. We will never change or remove existing functions from the API because we need them ourselves. So the little pictures you're seeing here is just HTML5 on our own API. There is no funny plugins based around Flash at all in these solutions. We've completely stopped using Flash altogether beginning of this year. So containers, just as a little refresh, bringing in this example, the Docker engine, but you can also apply the same to Kubernetes. So who of you used containers with Docker so far? Kubernetes, anyone? Okay, so you use both? Which one do you like most? Yes. Okay. So this is what I hear from a lot of customers. At a small software company from Walldorf, there's two religious parts in the company. One favors Docker Swarm, the other ones are fighting for Kubernetes. And I think this war will never end between these two departments unless one of the project dies. There's different approaches to containers, but the main idea behind it is to get rid of the hypervisor altogether, because it puts a burden on top of it that is not desired. In the beginning, when hypervisors came out, they used to steal 50 to 60% of your machine's performance. Today, we're at around 5 to 15%. So yes, they've become better, but they are still stealing. And the main issue is you have to run the operating system. You have to patch it. You have to keep track of it. In a container, I don't have to. We have one customer in France. They are a bank, and they are doing, I would say, is a VDI container towards their employees. The main idea there is they don't get a local drive. They just get application streams. The concept is you have a single operating system for everyone. So you don't have to install 30,000 operating systems. keep them patched, remind people, hey, it's Friday, please reboot your machine, you have an operating system patch. Something goes wrong, the user has to get somebody to go to his place, fix his machine, and they are doing containers on Windows for all of their applications. A lot of the stuff is web-based, so only a browser is required, but they also have things like Acrobat Reader in specific versions so they can sign stuff. But they're doing the container approach in order to better the user experience. They don't want people to be clogged with problems around their computer. They have an issue, reboot the machine first. Then wait, let it boot freshly, run the container again. You don't need to call IT department. This also works with, let's say, very, very IT uneducated people, as the common problem with a lot of clients is layer number 8. And layer number 8 is over here, it's the end user. There's also something called Manila in OpenStack. Manila is file share as a service. So whenever I have the need for simple file shares, so I can ingest data over NFS or CIFS, I can use the Manila project. It was brought into life by the OpenStack Foundation and Netup together. And it gives you the ability to kind of like consume like Cinder just for file shares. But some of you, I think we talked this morning about HDFS, the Hadoop file system. It will also give you a Hadoop endpoint where you can directly store data into and read from it from a different version. So you don't need to put Hadoop into your virtual machine. You can simply access the Hadoop share or the Hadoop file system from your container. So you don't need to load your container with additional binaries regarding Hadoop or need to run 10 installations of Hadoop in a university. You can reduce it to one single cloud location. And you could even share this across universities with only the deltas being exchanged between the universities. So if the link isn't strong enough, you don't have multiple 10 gig links between your cooperation partners, you can simply exchange only deltas on HDFS. And one of the last things I want to talk about is something we call NPS, Netup Private Storage. This is a product of ours. The idea behind it is you're using a Netup storage, but you can use the CPU and memory of public clouds. So whenever you have a project where your data may not leave the German law region, or if you're not allowed to share your data outside of your university, you could use this to grab additional CPU resources, memory resources, GPUs, for example, or HPC, or whatever you want to do with your stuff. You can use dedicated links in specific co-location data centers, because they have the uplinks to Amazon and the others. Here in Germany, we have 3 partners that we're working with. The closest one is in Frankfurt. It's called Equinix, a large data center provider. There's also a smaller one in Darmstadt, which is operated by a private entity. Darmstädter Rechenzentrum is what they call themselves. They operate these links, and you can send your data as a batch to them. You don't need to have a live link to that data. You just send your batch for processing, get it processed and download the results, but you don't need to give up your data to an American-based service provider that says, I have my data center in Germany, but they still oblige to the Patriot Act and need to share data with FBI, NSA, whoever. So you keep control of your data. These are figures for the live part. Any questions so far? Yes. So the actual working is you need to have a filer in your data center. You mean the NPS one? Yes. This one. No, no. There is no file moving there. Over this orange link, we're gathering CPU and memory. So the boot happens in here in a gateway appliance. We're just consuming their resources for CPU, memory, and GPU. And the file system is being accessed over NFS, iSCSI, or S3 on here. They are loading parts of the data into memory, but they are not actually grabbing the file and storing it on an cloud provider file system. To Amazon, we're seeing below 1 millisecond from Darmstadt. Frankfurt is even better, because Equinix is holding parts of the Amazon cloud. So they are even below a half millisecond in terms of latency. It is enough to run databases, to run batch jobs. I don't think it is enough to run VDI or to actually work on VDI-like images, but if you have the need for HPC processing and don't want to build a whole cluster and just want to run a single test job and want to rent the resources externally, this is the right solution, or one of the solutions you could use. Yeah. Exactly. So you could steal from the memory if you were the evil NSA agent, yes, but we don't copy over the file into there. The main problem with Amazon is you can't decide where your data lands. You could select a specific region, but from there it's out of your control. They could copy it 10 times without you even knowing it, even though you just ordered or paid for one version. Yep. Yep. Yes. It is still fast enough. There's this small biological company called Merck in Darmstadt. They are doing it. They stopped one of their HPC clusters, which they had to renew. They simply shut that one down. And they are actually using this service together with darts, because the line from Merck to darts is about 600 meters. This is all they needed, is a big dark fiber to their data center, because they had a lot of let's try something HPC-like jobs where they didn't know, is it worth processing? Do we really need this data? And actually it turned out this was cheaper to be run on Amazon CPUs and GPUs than on local ones due to the energy consumed, because they had to run this cluster for 24/7. And here they only need to run it on a case-by-case basis. But always keep in mind, if you're moving data to Amazon, they will not allow you to run 1,000 machines in like this. You can reserve 20 instances and you can have 20 running instances. Afterwards, it will ramp up very, very slowly. So creating an HPC cluster of 1,000 compute nodes, it will take a few hours, if not days, until everything is powered up, but you pay per minute. So this is the cloud tax that always applies, that you have. Sounds cheap to have 0.003 cents per gigabyte, but this is just the storing. The retrieval of data from Amazon is up to 45 cents per gig. So if you store a petabyte, very easy to store, but it's not that easy to restore out of Amazon. If you keep it internal in their cloud, no problem. But if you want to move it back to your own data center, there is quite a high cost involved. There was... So basically what you're trying to do is you have an existing NFS share and you want to sync that one to Manila and then share it over HDFS. Yeah. Then I would use something else. It's also a product, but it's a cheap one. It costs €0. We have the ability to run copy jobs from NFS to NFS. So your NFS share stays the same. We just run our Snap Center in between and ingest the data over NFS into Manila. What happens is you create a job that says look into the share IOG for any changes. This runs as a running process. We're mounting this file system in here, and we're also mounting the other side. But the traffic flow is directly between the systems with less burden, than it doesn't need to be processed here. So we're just basically doing a graphical rsync, if you know the tool, but it's not directly rsync that we're using. It's a proprietary tool, but we're syncing this one to over here in a version. If you get the results, so they are in bio results, we could also share them back into a different share for processing. So you don't exactly. The typical answer in IT, it depends. How big is your data? How big is the link? How fast is this server? How burdened is this one? Is it a physical installation? Is it a virtual machine? Is it running dedicated? Is it running shared? There is no real answer. From experience from projects, I can tell you we are able to max out the lines you provide to us, unless they are 100 gig. Oh. You're losing the typical 1 to 2% of TCP overhead, which is common, but you're able to max out the cable if you have the bandwidth available. Even cross data center, but it depends what your complete use case looks like. So you wouldn't need to run Manila. You could also use storage grid, or in this case, I would recommend AltaVault, which gives you an NFS share, but it stores the object in storage grid in the backend. So your NFS file will become an object and could be retrieved over S3 Explorer on any place elsewhere in the university. All you need to do is give the bucket key to somebody else and say, here's the file, feel free. So you could even move away from HDFS if wanted at some point, or simply store over HDFS and still store a S3 compatible object. So you don't have to worry about file system scalability, which you would have to do here. Oh, a hard drive is broken, bad. How many copies do I keep? Where do I keep them? What happens if this building over there is being renovated in 5 years and you need to move the whole data center? Which is the most annoying part, is migration. I think nobody here in the room has fun migrating half a petabyte of data, keeping track of it. So the idea is build a grid-like storage, place it anywhere on your campus. If one room goes dark, the others will hopefully survive, and your cloud is still intact. If you need to grow that system, put in a new one. If you need to age out old systems, I mean, it's eBay, PayPal are different companies. They don't remove broken hardware from a rack. They wait until the whole rack is broken and replace the whole rack. But this doesn't apply to, I say, European customers or German customers. They are doing it differently. But they are also penetrating their infrastructure. To second the security stuff that was mentioned this morning, they are using Chaos and CrashMonkey. Those are little scripts that are killing your infrastructure. This is the easiest way to teach your developers to write proper code. Because in the cloud, there is no such thing as my hardware. There is the hardware, and it could always fail you, so your application needs to prepare for that. This is why the object at this point helps you because you can store checkpoints from which you could restore. Ransomware doesn't hurt you. You can always take a snapshot. I have 2 customers who were hit by ransomware 4 weeks ago. All they did was hit the restore button because they are taking a snapshot every 30 minutes. They don't care. They lost 30 minutes of work. It was more work for them if they would have to restore or send somebody. They said, okay, sorry, you just lost 30 minutes. Next time, please don't click the Telekom-Rechnung.exe in your email. So there's always enough options for you. Any more questions? So we have 20 past 4. If you want, I can show a little bit of storage grid GUI, but we can also do this later during the poster session. If anybody is interested, we'll be waiting here for you. Otherwise, thank you very much for your attention and have a great summer school. Thank you.